There's a lot of complex math hidden away in this eye chart. It doesn't just tell you if you need glasses, it tells you something about the fundamental limits of human vision.
And we wanted to put that math to the test, on a slightly ridiculous scale.
Oh, we've got the Coast Guard coming by.
Well, let's back up. The chart is designed to measure one very particular aspect of our eyesight, visual acuity, or our ability to see very fine detail. It's basically the resolution of the eye. Now here, resolution isn't measured in pixels, it's measured in degrees, like of an angle, which is weird, but here's why.
Say you're looking at two lights shining at you from a distance. You can tell them apart because the light from each source is traveling through your eye and hitting a different set of light-sensitive cells called photoreceptors. If you move those lights closer together, they'll start hitting photoreceptors that are closer to each other, especially because as the light travels through the eye, it spreads out a little bit. Eventually, the two lights will blend together and your brain will start to interpret them as one. That angle between the two paths of light, right as you lose the ability to pick them apart, that's the resolution limit of your eye. For healthy adults, it's on the scale of just 1/60th of a degree, also known as 1 arc minute.
Snellen's eye chart is designed with this resolution limit in mind. Take that little E in the middle. It's built on a 5x5 grid so that the black lines and white spaces are all the same width, about a 1/16th of an inch. If you stand 20 feet away and look at that little E, each little black bar or space is exactly 1 arc minute thick. If you can read most of the letters in that row at 20 feet away, you have 20/20 vision, meaning at 20 feet, the patterns of white and black are just at the limit of your eye's resolving power. Now, you might be able to read a row or two beneath 20/20. Most adults actually can. In fact, 20/20 was never defined as perfect or even average. It's just a baseline to measure everything against. The row beneath that is the 2015 line. That means if you have 20/20 acuity, you'd have to walk forward 5 feet to see it clearly. Whatever your resolution limit is, you can use it to calculate your own acuity at different distances. Based on the Snellen chart, Rachel's acuity is a bit better than 20/20, which makes her maximum resolution just under 1 arc minute. So let's have a little fun with that. All we're going to do is plant you in front of this window right here, and we're going to go out there and show you some very, very large E's, and all you have to do is tell us if you can identify the E. We'll start small. That pier is about 1,500 feet away from us. Since Rachel's acuity is a little better than 1 arc minute, she should comfortably see an E if it's about 25 inches across.
Hello?
Hi.
Hi. I am going to show you an E, and you tell me
If it's facing the right way, if it's backwards.
Okay.
Okay, ready? Which way is the E facing?
The open part of the E is facing towards the sky.
Perfect.
Now for the big finish. Treasure Island out there in the bay is about 2 miles away. So to pull off the same eye exam, we're going to need a much bigger E, like 15 feet tall. Here we go. All right, gently, gently, gently. Oh, wind's catching it.
Can you see it?
I see an E, and it's pointed to the right.
And it is pointed to the right. That is correct.
The last thing to mention here is that acuity is important, but it's not the be-all end-all. Your ability to sense movement, color, contrast, depth, all of that factors into successful eyesight. So acuity is just one tool of many to help you make sense of the world.
Oh, we've got the Coast Guard coming by. We are happy to be here testing the Coast Guard on their visual acuity.
Okay, I think we're done.